Okay, next up is Murali.
Hi, I'm Morley. I'm working the build health team in Google, and we are in charge of shaping the build graph for Google. And I created a tool about 10 years ago on automating build files, and it's widely used inside Google and supports 20 plus languages and gets about 250K requests a day. So I must have done something right. So the hope is that, but unfortunately, it relies on internal Google technologies. We can't open source it. So we thought, okay, the next best thing we can do is I can at least tell what learnings I have made so others can learn from my mistakes. Okay, so first, what is build automation, right? So automated build file management is basically a process or tool which manages build files by making edits only on build files, and the source of truth is something else. So in particular, editing, formatting BZL files, editing your Java CC files, removing unused imports in your Java code is out of scope because we touch only build files and nothing more. In scope, creating build files, deleting build files, formatting them, editing them. Of course, for formatting, we already have Bulldozer, so we just call out to Bulldozer and don't reinvent it. So where can it be used? So you can use it as a save hook in your IDE. So every time you save your CC file, transparently this tool runs and it takes care of your dependencies for you. Or if you're the VI Emacs person, you go VI Emacs, do your thing, and then you run the tool before you do a Bazel build. Sorry. Or it can be part of your CI workflow. You make your code changes, send it to CI, and CI will say, hey, you forgot to add these dependencies. Or no, this is a big dependency, please replace it with a small one. And lastly, and more importantly, it can also help code janitors with their build changes. So for example, think of a person like, okay, I want to replace package.1 class with package.2. So I can do my find, grep, set, whatever, make the change in your code base. And then I want to say, hey tool, I just made a bunch of changes. Please do the necessary needful things. And I just replaced, focus your attention on these two classes. It's important to focus your attention on just these classes because you don't want to fix the world. You just want to fix one little thing to make things easier for the reviewer, for example. So what are the things which an build file automation can do? It can optimize the dependencies via static analysis. That's the easy part. It can add and remove rules as needed, because it can also recognize rules which are no longer needed. It can add new build files, which is a nice way of making sure that your packages don't grow very large. It can help refactor rules. It can help avoid common mistakes. For example, like how often do people write a foo test.cc and, hey, I've written my test all good, but oops, I forgot to add a CC test. So the test was never run. Right? And can also help enforce various best practices. Like, do you have too many sources in your rule? Or do you have too many rules for a given source? So these are all problems in their own way, and the tool can help you identify these things. So first question is, why do you want to optimize dependencies, right? So pick a Java library rule. Let's say we have a dependency which is used, one which is unused, and one which is missing. So what's wrong with this? Missing dependencies are bad. Why? In some languages, of course, they break the build, and nobody wants a broken build. But in other languages, if you know that there are no missing dependencies, you can make the builds more efficient. Like for example, in Java, right? If you depend only on these 5 dependencies, then when you call the Java compiler, you only need to pass those 5 jars to the Java compiler and not the transitive closure of the jars. So that means the action executes faster and builds go faster. Unnecessary dependencies are also bad because they unnecessarily slow down builds. Because why wait for an action to compile something which I'm never going to use it? And it increases binary size because nobody wants to download 2 gig binaries. And of course, even in cases like, say, C++, where there is dead code stripping, the linker has to do a lot more work. Because if you know that you don't need it, don't give more work to the linker. Okay, so all this, so now we know why we need to optimize dependencies. So the first things you need to do, one of the crucial things you need is to resolve imports. So what is an import? Resolution is basically mapping an import to a build target which provides that. And when I say import, I mean it generally, like in Java, it's called import. It's in C++, it's include. For BZL, it is load, and so on. So each language has its own terminology. So import is in general, right? And the thing is that imports may or may not correspond to types in your language. Like in Java, you import classes and methods, which are symbols. In C++, you import headers, which are not classes, right? So imports may not correspond to types. So let's look at different ways to resolve imports. The easiest way is just use string manipulation, right? So I have a Java library which has foo.java, and I see an import for alt bar baz craft. So where is the target which provides it? Hey, it must be alt bar baz craft, right? It's very easy. The mapping is trivial. I just replace the dot with slashes, the last capital letter with a colon, lowercase it, and I'm done. Right? This works perfect. And there's no need to interact with Bazel. It just works. And it is so fast that it can be an on-save hook. So what's wrong with this? The problem is it requires your entire code base to satisfy this condition, right? So you need to guarantee that every alt bar baz craft.java is present in that particular location, which may not be possible if you have third-party dependencies, because you don't control the code which you import, and you cannot rewrite things. And we know people like to use sources equal to glob. You glob everything together, then clearly these things won't help. The other problem is it couples your source code with your labels, because it adds friction to code janitors. Because now let's say I want to rename this class. That means in order to keep following the naming convention, I also need to change the build graph. So coupling these two makes refactoring hard. Okay, there are some other cases where this thing doesn't work. Like in this case, I have a package which spans multiple directories. So even though I have alt bar baz craft.java, but my build file is one level higher up. So which means in the previous slide, the position of the colon is in the wrong place. Another case is, well, I have the code all correct, but it is not in alt bar baz craft because all my Java code is inside some other directory, right? I imported from Maven. So it's there inside something /source/ whatever. So in this case, the Java package and the Bazel package don't align. So how do you fix this? Well, throw in some configuration, right? So add some configuration which says that, hey, this is a Bazel package. This directory does not have a Bazel package. You need to go up one level to find the Bazel package. Or you say that, oh, this is a new Java source root. Like for Java packages under this, please look there. Well, that allows you to handle violations for some conventions, but what if the rule is named something else? Like people can do whatever they want. And if you start having configurations for every one of these, then you're essentially building an index. And then you have the problem of, okay, how stale is the index? How fresh is the index? Is the index manually maintained? In which case, if you end up with a manually maintained index, you end up saying that, hey, instead of writing a build file, you're writing the index file. So you're back to the same problem all over again. But none of these will account for violations caused by local changes in my client. Like I've made some change in my client right now, and now I want to run the tool. Can the tool adapt to these changes? So these are some problems with this approach. So let's look at another approach, right? So we want to, let's say we're talking about Java. Who best knows about Java than the Java compiler itself? So let's rely on the compiler, right? So we just change the rule implementation or add an action, add an aspect somewhere, and use that to discover what imports are required and provided by each target, right? So for example, if you have a code like this, the action is going to generate some output like that. Okay, this thing provides these two classes, package.outer and package.outer.inner, and it requires these two classes. Note, in this case, by looking at the code, you do not know whether helper actually is an inner class of JSON reader or it is a package private class. There are two different interpretations for the same thing. The compiler knows, at least it can know if it has the right dependencies. So once you get the compiler to produce this output, then checking your dependencies is simple, right? You just reconcile all the required list of your target and compare it with the provides list of all the dependencies. Right? So what is the pros and cons? So in this case, the compiler understands all the language nuances, so you don't have to worry about it. You don't have to worry about naming conventions because you don't care. And if you're missing dependencies, then if the right dependency happens to be in your transitive closure, then it's easy because you have done this, getting this list of requests and provides for your, like, let's say you run an aspect, right? So you have this information in your transitive dependency, and you can say, hey, that particular target, this was there in its provides, therefore it should be here. For unused dependencies, again, it's easy, right? Almost. Because you can just say that, hey, this dependency provides this class, but my target never required that class, so I don't need it. Of course, there's a corner case where if you need one class which is provided by two dependencies, then which one do you remove? That's a problem. And it may be consistent, it may not even be consistent across fronts. Like, let's say if it's a Java compiler, then depends on which jar it happened to read first, that may affect the output. But the downside is you need to build. Builds can be expensive. And you need to know what flags. Like, am I building for this architecture, that platform? I need to know all those things. But I'm just looking at the imports from my Java code. Do I really need to know whether I'm going to compile for Android Nexus 1? The other thing is this works only if you have syntactically valid code. If you don't have, if it's not syntactically valid, your build fails very early and you have no information whatsoever. If your dependency you're missing is outside your current transitive closure, you have a problem again. So you need some logic outside Bazel anyway. And finally, it is not easy to do this for all languages. For example, for C++, like we include headers, but the compiler and the linker only care about C++ symbols. So the connection is not obvious. Like, do you instrument the preprocessor? Do you instrument the compiler? They don't know. So here's a third approach which we found useful. Just automate the user. What would a human being do? Right? Looks at the source code. Okay, I read the source. I see this import. I see that I'm importing this, so which means I care about this class. See that I drop the inner because it's an inner class. So these two classes are tied together. Therefore, I only need to resolve the outer class. Then I need to look at the Java roots. So this is where I still need some configuration. And I'll say, okay, I'm going to look inside workspace. Okay, so this is a possible source. This is what I want. Is it there? Find the rule which corresponds to that. We'll get how do we do that in a second. And then add the dependency. So just automate the user. So how do we find the rule? So let's say we are looking for cruft.java. And as part of looking, we realize that the build file is not there. It's one level up. So we discover this as part of resolving. So we don't need any configuration, nothing. And we see something like this. So we see, okay, I see two Java library rules with cruft, and a third one, which is a macro, which also has cruft. So all three are good candidates. But then I realized that, okay, I use Bazel query, look inside and see that, hey, actually checklib is nothing to do with Java. It just generates some sh test, which maybe greps the Java file to see whether some bad strings are there. So that is not really the right rule. So which means my choices narrowed down to two, 1 and 2. But 2, the problem with 2 is that it includes an additional source, which means whoever is depending on this is picking up unnecessary stuff. So I shouldn't use 2. So which means I'm down to 1. But 1 has private visibility and says, as a deprecation, saying do not use. So what do I do? Then, because I know the entire package, I can look down further and see that, hey, the last rule API that exports 1 and that has a visibility to some package group. So which means if the rule I am analyzing is in this package group, then I'm good. I can use that. If not, I know that I need to change the visibility of this package group so that it is made visible. So all this is what a human being would do, and we can just automate just that. And how does this compare with the other approaches? So this understands the rule semantics. Right? You need to understand the relationship between the rules. What does the exports attribute mean? You understand that this macro generates an SH test. I'm looking at Java, so I don't care. You need to understand the language semantics. It adapts to all local refactoring which you have done on your client. It degrades gracefully if resolution fails. So for example, in the previous step, like if that for the string manipulation, if the target doesn't exist, then the tool will succeed. You do a Blaze build and it will say just fail, no such target. Here, as part of the resolution, we are kind of verifying that the target exists. So the target didn't exist, I would fail early and say that, hey, I was not able to resolve this. You human, please do it. And this does not need a build. Like all we need is Bazel query. We don't need to do an expensive build. The downside of this is that it depends on Bazel query. So interim versus string manipulation is fast, so this is not as fast. We still need some configuration. I need to know where the Java roots are, like Java code may be here, maybe there. It needs to understand some code generation. Like if I have a gen rule which produces a foo.java, that's good. I can immediately see that it produces foo.java and I'm done. But the problem is that foo.java hopefully is in the same the package. I don't know till I execute the gen rule, but I don't want to execute the gen rule because it slows things down. And one of the big cons is that there's limited support for preprocessor directives, right? So let's say we are talking C++ and you have a hash if def. So what do? I can assume, all I can do is assume that I need to satisfy both the hash includes, and I give you two dependencies. But in practice, you don't want both of them. You want exactly one of them. I don't know which. So we'll end up adding both, and the human has to say that, okay, I'm going to take those two out and put them inside a select and say, if POSIX, then do this, otherwise do that. Okay, so now we have finished the resolution. Now the next thing to do is to update the build file. So that should be easy, right? So there are two main ways to do it. So one is what I call syntactic edits. So what happens is the tool internally generates the rule which it expects to see in the build file. So Java library, foo, sources, whatever. Then it looks at the build file to see, is there a rule like that already? And it matches by the name of the rule or the type of the rule. And then it tries to reconcile the two. So for example, if the build file currently has foo with some sources, some visibility, and deps as X and Y, and the tool internally says that, okay, I want to create a Java library for foo whose dependencies are A and X, then it matches this with this and says, okay, I'm only going to change deps to what I think it should be and leave everything else alone. So which means any comments, any visibility, whatever is there is still left alone. Because if you overwrite the whole thing, then of course that's bad. Okay, so the good thing about this is all comments and all attributes not managed by the tool are preserved. So that's good. There is no need for Bazel query. Therefore, it's fast. The cons is that it's sensitive to the matching logic. And when macros are in play, things may not work out well. Right? So let's say you have a build file with, hey, this Java library has foo.java in its sources, but it's named something else, and it has an additional bar.java in its sources. And there is something with foo.java in its sources, but it is not a Java library, it is some magic library. Like, I don't know what it is. Maybe magic library is a macro which just says I'm Java library. Right? Or maybe it is Java library together with some additional checks. So you don't know how to merge these things. So it's a problem here. The other way to do it is to what I call semantic edits. So you start with a source file and use Bazel query again, and look for rules in the package which has foo.java in its sources, right? So let's say this is your build file, right? You're loading mylib, which has a macro and has sources equals foo.java. It is not srcs, but some sources. And turns out that this BZL thing, what it does is it just creates a Java library whose name is slightly different. And for fun, it renames sources SOURCES to SRCS. And it takes an additional argument called Java deps, which it maps to deps. Okay. But because we use Bazel query, I'll actually expand the macros, and I will see here that I have a Java library rule called foo_impl with sources equal to foo.java. And now that I understand the semantics of Java library, I can go do my analysis. And then the result of the analysis tells me that, okay, I need to set the deps for foo_impl to bar. Then I go back and look at the macro, figure things out, and then I will convert this and say that, okay, if the semantic change of foo_impl.deps equal to bar should be converted to the syntactic change of foo.java_deps equals bar, right? In order to get the deps of the generated rule to be bar, I need to change the Java deps attribute of mylib. So that the semantics to syntactic mapping needs to be done. And then you apply your changes and you're good. Right? So what are the advantages of this one? Right? So everything is driven by the bill graph and rule semantics. So there's not much guessing going on here. Naming conventions don't matter because I'm just going to look at the output of Bazel query. I don't care what it's called. All I care is it has foo.java in its sources. Macros can also be supported just fine. The only thing is I need to know the mapping for from foo_impl.deps to foo.java_deps. I need that mapping. Okay, and all we need is to associate some metadata with the macro and expect the macro to satisfy some best practices. Right? Of course, the downside here is I need this metadata. And we can make it easy. And the thing is, Bazel already makes it easy to get this metadata in some ways. Like, for example, if you look at the output of Bazel query, the line right here basically tells me that this, this should be Java library, but okay. So this Java library rule was actually generated by this macro defined in this BZL file. So once I have this information, I can go look up that BZL file, and basically we have a comment or some pragma you can add there, which gives you the metadata you want. So let's say you decide to implement this on your own team or company. So what do? So my suggestion is that if you can force your will on your entire code base and declare that, okay, everybody has to do this way, and you must name this way, etc. And any external code you have, of course, you can't enforce your will on the entire code base or your external dependencies, but what you could do is you could transform them when you import them, right? If you're willing to do that. And if you only care about dependency management, because so far we have been only talking about just the dependency part. Like, for example, you don't care about visibility. Like, if it's not visible, okay, the human being has to go do it. In these cases, then I think the best solution is to just use string manipulation for your resolution and just deal with syntactic edits, right? So this is going to be fast. There is no requirement for Bazel query. That's the main reason why it's fast. And I mean, your latency you could expect around the hundreds of milliseconds. In the other case, I would suggest that you just go all in on Bazel query, automate the user, and use semantic edits, and your latency will now be 1 to 2 seconds, right? This is what we have got. So what do we do in Google? For Go, we actually use the string manipulation and syntactic edits because the language was created late enough that we could enforce our will. For all other languages, we automate the user and use the semantic edits. There's some small number of internal languages which my tool doesn't support. And for Java and Kotlin, in addition to automating the user, we also rely on build artifacts, primarily to remove dependencies. It's hard to add dependencies, but it's easier to see that something was not used. So that's especially useful because Java and Kotlin have a lot of generated code. So it makes sense there. Okay. The last section is how you can help make your build files more tool friendly, right? So why do you want to make them tool friendly? Because it's easier to make them easier for tools to edit, and more importantly, it's also easier for humans to reason about. Remember, build files should have no logic, pure data, declarative, and stateless. That's what you should aim for. BZL files, they have to be pure logic, no data, which users care about, and you care about the API, like how clean it is to use. For example, avoid variables, right? So yes, you can do this in build files, but it's not a good idea because this makes tooling hard. Right? If I want to change the dependencies of this rule, what do? Do I add something here? Do I edit this variable? But maybe this variable is used somewhere else, like here. Then it'll affect that also. It's hard. Instead, what you should do is, like in this case, this is begging to be refactored, right? Because this is a mapping from sources to dependencies. So make it explicit. Let Basil know about it by creating a rule with that name, and you have the same thing. And now things are a lot easier for tools to manage. Macros. Don't add convenience steps, right? You can have a my library with sources equal to foo, and your macro says, it's trying to be helpful and says, you know what? I know you don't want to keep typing these dependencies over and over again, so I'll add this whole list of things just in case you need them. The problem is that my tool can tell you that, okay, you don't need utils, but I go look at the build file, I don't see a utils to remove. So there's nothing I can do. Right? So this leads to more unnecessary dependencies, which, as we know, is bad. Third thing, avoid list comprehensions. So here's an example of a list comprehension, right? You're trying to be helpful. You're saying that, okay, I have a bunch of sources. For each source, create a library rule with that source and a bunch of dependencies. The problem now is that the sources are different. They have different imports. So shouldn't they have different dependencies? Why are you forcing them to have the same dependencies? So now this forces the dependencies to be the union of the dependencies of all of them, which means that when any of these dependencies change, right? So if any of these change, then your CI pipeline will have to treat all of these rules as dirty and rebuild them and retest them unnecessarily, right? And especially if you are paying for compute, it can add up. Okay, at this point, I'll stop. I have much more slides, but for lack of time, we'll stop and time for Q&A.
So I have two questions. So first one is, how did you solve superfluous dependencies? And second I have is, how much gain you got by building this tool?
So right now, everybody in like half the developers in Google are using this. So the idea is that by people don't care what dependencies you add as long as it builds. So you use that to your advantage and try to shape the build graph and say that, okay, I'm going to start moving people over. So, and they don't complain, their builds work. And that also means it helps the owners of other libraries and says, okay, somebody says, okay, I have a rule with 100 sources. So I use the tool, split it into 20 rules. And then that's the easy part. The tool can help. The hard part is, now how do I go and find all the people who use my rule and fix them? Well, they don't have to do it because they can just walk away. And then when the other users use the tool on their code base, the tool will automatically figure out that, hey, you're currently depending on this rule, which has been refactored into 10 or 20 pieces. You need these 2 pieces, so I'm going to optimize this for you. So you start pushing everybody in the right direction. And I mean, one of the features we have is that you can automate this also. You can say that, okay, once you have sharded the rule, you can just run another variant, another flag to the tool, which will basically say, find all my users and just fix them for me as well. Other questions?
So on the last slides, you presented like build cases that we shouldn't be using. Have you thought about automating fixing those?
Which one?
These ones and the ones before. So have you thought about having an automation that would fix these solutions, so like
Yes.
convert from before to after?
Yes, I actually did. I do have another tool which helps for things like this. And I did run it across Google Tree, and we removed all variables which are used for dependencies alone. The problem is in some cases like this, where you have a variable which is used for dependencies and which is paired with a variable which is used for sources. At least, okay, what I tried was just inlining these variables, right? But that is the wrong thing to do if these variables are paired with other variables. So the tool, I specifically recognize those situations and leave them alone, because there the right thing to do is to actually refactor it.
Hi. I just have a comment on this because this connects very well with a talk we had before that said something along the line of adding type annotation to Starlet. What I have been observing from users so far is having to learn how to edit build file and BZL file in general is a pain, right? Not having editor type completion is a pain. So I think the way Bug2 has been solving it is adding type annotation into it and then provide IDE support for it. But I think this could be an alternative direction, which is completely automating. I was just thinking, like, is there any direction that you guys willing to lean toward in terms of supporting the open source community? Because right now the direction is kind of unclear, and it seems like both can use a little bit of help from the Google side.
So one thing is, you need to, even though build and BZL are tightly related, you should think of them completely different things. Like, think of BZL as your Java code or C++ code, and think of build as your CSV file, your JSON file. Like, it should be pure data, right? So which means the tools which work on these, like for BZL, it's unlikely that any tooling, automated tooling is going to help. You'll need more like help from JetBrains. Those kind of refactoring, like what you do for Java, the same kind of tools you need for BZL. For build, the hope is if you don't do things like these, if you don't stop treating build files like a programming language, then automation can come and help a lot.
Yes, hi. I'd be interested in for parsing and editing the build files. What are those Google internal tools, or do you use like Bulldozer for rewriting the file?
Yeah, so we just use Bazel query to generate the query output and see the generated code. And then we look at the call stack, which output by Bazel query that tells me which BZL file defined the macro. I just go to that BZL file, look for, we have, think of it as pragmas. We have pragmas, which macro authors can basically add metadata saying that, hey, my macro looks like this. And then we use Bulldozer to make the edits.
Questions?
That's a problem because we are only using Bazel query, which means we only know the loading phase information. So which means we essentially flatten selects. So we are treating as if all the dependencies are needed. And when we generate the dependencies, we will add all of them together. And a human has to look at it and figure out what the select is. Because like, I don't know whether you want to select based on the CPU or the platform. There are multiple ways of doing the same thing.
Thanks, everyone. We're at time. We have a 5-minute break. Lightning talks at 10 before the hour. So be back then and take a short break. Thanks, Murali.